Urgent. A sudden traffic spike hits your site, and the server chokes. Frustrated visitors immediately start complaining about sluggish load times. Eventually, the queued connections drop entirely, and the browser serves a dead-end 503 service unavailable error. The standard industry advice for this problem is immediate. Buy a virtual private server to secure more CPU and RAM. That advice treats hosting like a storage unit. It assumes that if you run out of room, you simply rent a larger one with higher numbers on a spec sheet. But a growing WordPress site almost never maxes out monthly bandwidth or disk storage. Those advertised top-line specifications are entirely irrelevant to a 503 error. Moving to a VPS changes the actual mechanism for how your site processes traffic. It removes the provider's configuration safety net and transfers massive operational liability directly to you. Upgrading to solve a volume problem means paying a premium to crash your site in entirely new ways, while adding mandatory IT chores to your weekly workload. Shared hosting measures and restricts traffic using an assigned number of entry processes. The platform grants your account a strict, invisible integer of simultaneous requests you can handle. The platform also provides a safety net. The server software queues excess traffic, holding connections for up to 120 seconds. Visitors experience this as a slow website long before an outright crash occurs. This diagram shows a standard shared bronze plan. The account receives 15 entry processes, which run inside a strict memory container. A single WordPress request can pull a massive amount of memory. If a few heavily dynamic plugins demand their maximum allocation, they shatter that memory ceiling immediately. The math is unforgiving. Shared sites crash because they trigger the kernel's memory killer long before they actually reach their assigned visitor capacity. A virtual private server removes the assigned entry process limit completely. You must manually configure your own maximum child processes in the server files. Looking at the VPS specifications, you see a massive jump in guaranteed RAM compared to the tiny shared container. However, a VPS is constrained by its processor. A standard configuration safely sustains a band of 4 to 8 active child processes for every single virtual CPU core. Apply that heuristic to a standard KVM2 virtual server. The CPU capacity maxes out at roughly 16 active workers. That ceiling is nearly identical to the original shared bronze plan. Upgrading to a VPS does not automatically buy a proportionally larger number of concurrent users. It buys far more memory to dedicate to each individual user. Capacity is only half the trade. Upgrading to a VPS grants you total root access to the server environment. This gives you the technical freedom to install custom server daemons, compile unique extensions, and run persistent Redis queues that shared plans forbid. This matrix compares the automated protections across environments. Root access requires the immediate forfeiture of every guardrail listed here. On a VPS, you own the configuration for all of them. The operating system patching previously handled by the host becomes your direct responsibility. You must monitor government vulnerability catalogs and apply kernel patches yourself. This is not a one-time setup step. Securing a server requires a relentless, recurring maintenance schedule that never stops. A VPS transfers sysadmin responsibilities to the buyer. An unpatched virtual server with generous resources is a massive security risk, making it a worse outcome than a constrained, maintained shared plan. Before migrating your hardware and taking on that liability, define your exact traffic profile to determine if you actually require more computing power. Consider the viral blogger. This profile draws thousands of simultaneous visitors who are exclusively reading static text and viewing images, with 0 users logging into the system. This flowchart tracks a web request hitting a properly cached site. The server intercepts the request at the cache layer and returns a saved response, entirely avoiding back-end processing. When you enable a tool like LS Cache on a shared plan, a cached visitor consumes 0 entry processes. Contrast this with the e-commerce operator. These visitors log into accounts, add multiple items to dynamic carts, and process active payment gateways. An active checkout flow bypasses caching entirely. The server must generate a unique response for every single click, forcing the PHP workers to process massive amounts of logic in real time. Throwing money at a virtual server is a wasted investment for static, cacheable traffic. But for heavy, dynamic loads, the dedicated worker memory of a VPS is an absolute necessity. The choice between shared and VPS hosting depends strictly on the type of system boundary your business is equipped to manage, not the size of the plan you can afford. This decision tree maps out exactly when to stay put and when to migrate based on the root cause of your bottleneck. If you run a high-traffic blog experiencing sporadic spikes, enable caching and stay on your current shared hosting plan. If you operate an e-commerce store dropping checkout connections, upgrade to a VPS strictly to secure guaranteed, unshared memory for those heavy requests. If you are an advanced developer building architecture that requires root access to compile specific system tools, you must upgrade to a VPS. If you lack technical expertise and do not employ a dedicated IT staff member to manage server updates, abandon the idea of an unmanaged VPS entirely. Execute a hosting upgrade only when you are completely prepared to trade the safety of an assigned ceiling for the responsibility of building and defending your own infrastructure. The choice between shared and VPS you can afford. This decision tree maps out exactly when to stay put and when to migrate based on the root cause of your bottleneck. If you run a high-traffic blog experiencing sporadic spikes, enable caching and stay on your current shared hosting plan. If you operate an e-commerce store dropping checkout connections, upgrade to a VPS strictly to secure guaranteed, unshared memory for those heavy requests. If you are an advanced developer building architecture that requires root access to compile specific system tools, you must upgrade to a VPS. If you lack technical expertise and do not employ a dedicated IT staff member to manage server updates, abandon the idea of an unmanaged VPS entirely. Execute a hosting upgrade only when you are completely prepared to trade the safety of an assigned ceiling for the responsibility of building and defending your own infrastructure.